Hello and good morning to all. Welcome to another episode of Steamboat. For those who are joining us here for the first time, Steamboat is an outreach program organized by Homi Bhabha Center for Science Education. On every second Sunday of the month, we come with a new topic related to science, technology, engineering, arts, and mathematics. So today's topic that we have is Indigo and its blue revolutions. And to talk to us about Indigo, we have with us Indrani Das Sen. She works in the chemistry education group at HBCSE. She works on the development and standardization of experiments for both undergraduate and school levels. Her interest specifically lies in the area of inorganic chemistry, and she has a knack for colorful inorganic compounds too. She has been guiding student projects in analytical and inorganic chemistry. So we start the session and I would like to tell you it is going to be interactive. So please put down your answers and questions in the chat section. Our Zoom viewers can unmute and ask their questions. So with that, I would request Indrani to start with the session.
Thank you, Vishal. So good morning to all of you. So today I'm going to talk about one of the very nice areas, and also one of the very nice color, that's indigo. And so I'm going to talk basically about history of indigo as a dye, the different political interferences that it encountered, the revolutions that it caused, and the current scenario and whatever is the current production of it. So let me start. So can you tell me what comes to your mind when you think about indigo? What comes to your mind when you think about indigo?
We have one rainbow with cure.
Okay, rainbow, yeah. Anything else?
Viewers, you can put down in the chat on YouTube also. Flight. One person, Mitansh,
okay,
has said flight.
Okay.
Indigo Airline.
Indigo Airlines, yeah. Okay, so what comes to my mind? Yeah.
There's one more, paint.
Paint, okay, indigo paint, okay. So there are a few things which come to my mind also. So first thing whenever I talk about indigo, the one which comes to my mind is this Indica car by Tata. There is these beautiful blue color birds which are found in the Himalayan region, which are known as grandulas. Ujala blue, which we have seen very often and used in our home also for whitening our clothes. The blue kingfisher, which is very common. Of course, you said Indigo Airlines, and not to mention the list is rainbow. There are many other things which we can correlate, but these are the common things which come to our mind when we talk about indigo. So in all this, we find that even if we are talking about it, something which is related to blue. You say something which is just related to blue, it's other colors or whatever it is, but something that is related to blue. So is this indigo, by the name which we call, is it different from blue? If it is blue only, how is it different? Is it light blue, dark blue? What exactly it is? Is it only color? What do you feel? Is it different from blue? What kind of color shades do you think it could be? Can I get some answers?
We have a couple of answers. Little dark blue with violet or purple.
Okay.
Another answer we have is it is some dark blue.
Dark blue. Okay. Okay. So perhaps is this the blue which we are talking about? The robin blue which we have used in our home? The blue in this flower, which is a very common flower found all over, it's in Hindi or it's called as Aparajita. The jeans blue, the bandli blue, or the blue color of the crows, crow eggs, or the blue color of this flower. So it's a water hyacinth, which is also called as Jalkumbhi. So we see that there are so variety of things, variety of colors, come to our mind when we talk about indigo, whether it is dark blue, light blue, whether it has a purple shade, dark purple shade, whatever. So let us then, what is indigo? Is it only a color? Only a color? Is it something which gives color to the fabric, like dyes, paints, color giving substances? Where do we find it? Is it found naturally? Is it human made? Do we have to go on mining for rocks, or does it have any plant origin? So today's session, we will try to explore these different aspects of indigo. So before we go briefly into the history, so one very interesting thing I would like to mention about indigo. So can anyone say who this person is? Okay, so anyway, so this person is Newton, whom we know from from a school days, and there is something related to him also. He had performed certain light experiments. So what we see here, we see just a prism, and white light is passing through the prism, and on the other side of the prism, the white light is getting separated into different colors. Yeah. So what does this have to do with indigo? What basically does Newton have to do with indigo? The separation of colors, until Newton, the separation of colors, they were divided into 6 different colors. In the modern context, we say, like one of you said in very earlier slides, Vibgeo, the rainbow, the Vibgeo. Whenever you say Vibgeo, you find that there are 7 colors, but until then, there were 6 base colors which were given. Newton introduced the color indigo, which was placed between violet and blue, sort of like a mixture of violet and blue. Whatever, you can talk it about dark blue also, whatever. So the color indigo was introduced into the spectrum by Newton. So now let me come to some historical facts. So the archaeological site in Peru, that is in Huacaprita, after excavation, people found out there were sample of clothes, fabric, which were dyed using this blue color. These were analyzed using modern methods, and after the analysis, these were found that the dye which was used to impart blue color to the cloth was indigo. Imagine that is 6000 BC, I mean roughly 8000 years before us. And then we come slightly earlier, even in the Indus Valley civilization, when it was excavated, there were 4 different seeds of indigo plants found in the Indus Valley. Along with the seeds, sample material of cloth was also found, which were dyed in blue color. So you see, indigo, and as a substance, as a dye which is used to give color to the substance, was from antiquity. I mean, 8,000, 10,000 years before people were using it. It's not a modern dye. It was being used. And in both these 2 cases, these were found to have plant origins. Obviously, in Indus Valley civilization, people unearthed different varieties of indigo seeds. So we see that it was known to people from very, very old times. So can anyone tell what is this picture about? Or can you relate this picture to any kind of civilization? We have encountered such kind of pictures in our history textbooks also, in our school days.
So viewers, can any one of you, we have one answer, like looks like Egyptian type.
Okay. Anything else? Yes.
Mitansh says, I think we should Okay.
Okay. Yeah, you're correct. It is a wall painting from an ancient, from Egyptian civilization. Wall paintings of Egyptian civilization. It also has blue color. Can you see the blue color? But the color is not plant-based. The color, after analysis of the color, it was found to be synthesized by humans. It had inorganic origins. So I'm not going to go into very detailed composition, but basically it had some calcium, some copper, and some silica. So it was made synthetically by these people. So this Egyptian blue color is often termed as first synthetic, not dye, but pigment. Pigment is a modern time term, but there is a difference between dye and pigment. Dye generally often have sources from plant origins, or they are often carbon-based compounds, whereas pigments generally are have inorganic origins and are generally they are synthetically prepared in the industry. Another civilization. This is another civilization. Can any one of you tell what is this civilization? Or have you seen it somewhere?
So do we have any guesses for this? Inca.
Okay.
We have something Inca, I don't know.
Yeah, okay. So this is a painting from the Maya civilization. The Maya civilization flourished from 8000 BC to 1600 AD and roughly like 10,000 years in the region of now present Mexico, southern Mexico, Honduras, El Salvador. So the Central American part, Maya civilization had flourished for around quite a long time. And for them also, the blue color was a very important color in their lives. They also had the blue color, which we see here, has both plant origin as well as like inorganic origin. When I say it's natural clay, so it was a mixture of plant-based origin and natural clay. So we see on one hand, Egyptian civilization is also using the blue color. For them, blue color was a symbol of wealth. Whereas in Maya civilization, we find that for them, the blue color was a symbol of different sacrifices, different rituals. So blue color was used across different kind of civilization at different times and is a very common color and a very well revered color, I should say. So this is also a World Heritage Site and it is in China. So can anyone tell what it is?
So I would like to take a guess. Okay. Yeah, I was going to guess something similar. Looks like small statues we have in the comment.
Okay, yeah, statues, yeah. Anything else?
Okay.
So these
I don't
are.
know. Yeah, I would like to take a guess. It looks like terracotta. Is it something similar to that?
Yeah, it is something similar. It is something similar, yeah. But yeah, so you are correct. You are correct, and also the person who answered is also. These are sculptures. So these are the Chinese terracotta army sculptures, and these sculptures have been painted using the blue color in this sculpture, which is not very evident here now. But once they were excavated, the blue color was there. But as soon as it got exposed to it, the lot of blue color just it got removed. So the color blue, which was used here, again was synthetically prepared. Now this is from roughly 200 BC or something around when BC, when he was the king. So he was the first emperor of China, Queen Shi Huang, and people during that time believed that if the army, if the sculptures were made and they were buried with him, the army would protect him in his afterlife. So that was the belief then. So that was the reason that the first emperor, that had such a huge burial tomb, and it's like roughly 90 square kilometers. So it's a huge area. And this is filled up with armies depicting generals, different ranks of armies. So we see the color is not again plant-based here. It's again has an artificial means. It's again a synthetic one. So let us come back to India. So indigo was also known. So we have seen that indigo was known to different civilization, but indigo was also known. We have seen in Indus Valley civilization, it was also known. So people were actually exporting indigo to the Arab countries, also the Middle East countries, the Central Asia. So these were getting exported. However, the mention, very clear mention about it was done by one of them. Previous, they may be, I mean, mention about indigo in the previous literature also, but at least the one which is very prominent was given by this person. Can you tell who this person is? He was an Italian traveler who had traveled extensively to China and India. And when he was in China, he spent a lot of time from there to India. For a few months, he was there at least in India.
So viewers, can you take a guess on this? On YouTube.
Okay, so he was Marco Polo, who was an Italian merchant, and Marco Polo had mentioned very clearly in his diary about the indigo production in India. However, he had mentioned it that it was during that time, the indigo production was in southern India, mostly in southern India, a few parts in the western India. So, but he had talked about in detail how these were manufactured, how the whole process was done, and these were getting exported. So a little ahead of him, we have this person. So he's known for finding out the route to India, sea route to India from Europe. So can you tell who this person is?
I believe this one should be easy. Someone should guess. Otherwise, I would take a guess on that. Yeah, I think this is Vasco da Gama.
This is Vasco da
Yes,
Gama.
we also have in the chat.
Okay, yeah, good.
Vasco da Gama.
Yeah, he is Vasco da Gama. We know about Vasco da Gama also from our history books. So Vasco da Gama had found out the route and had already started importing indigo to Europe. So prior to that, indigo was again was already exported to the Middle East countries. But these were the people who had specifically, like Marco Polo had specifically written about it, whereas Vasco da Gama was also doing it, and it has been already written down. Coming to a more like ahead, we have this army. So I will not right now. Let us go ahead. So this is the uniform of the French army. Basically, it's a painting, but the painting of the French army. And these are the blue uniforms, and these blue uniforms had the color blue was from two sources now. Both are plant-based, but two sources. One was the woad plant and the other was the indigo plant. So what are these two sources? We'll come to it later, but let us for now understand that there are two sources, two plant sources of the indigo, and what kind of political pressures these the competition and the political pressures it caused. So here we are here now. So let us see now. So during that time, like 15th or 16th century, the Ujjain was one of the places known for manufacture of indigo from indigo plant. It was exported to Middle East, Europe. Surat was a very huge port. So the indigo was, both through the Silk route as well as to the sea route, indigo was getting exported. It was such a in high demand, and it was also such very due to its very high profits, people used to use it as a currency for the daily expenses. Also, when people travel for the daily expenses, also people used it for as a currency, and of course for its high profit, it was also a luxury item. So because of all this, it was termed as blue gold, because it was such in demand. The price was extremely high. It was not easy to find. India, Philippines, and I mean basically Southeastern countries were the only place where where it was getting manufactured. This indigo, you had another source, but there was also competition. So it was called as blue gold. Strips of indigo dyed cloth were also used in African trade networks in the 15th century. So we see indigo was used both as a currency, and it was such a luxury item, it was called as blue gold. However, the European source of the blue dye was the woad plant, which we just discussed. So import of indigo from India to Europe, obviously, it devastated the local trade. In some countries like England, France, and Germany, there were death penalties also given in some cases. Restrictions were already in place, and death penalties in certain cases were also given. So the other way is that in Central America, there were competition between the Spanish merchants and the Dutch, Indian, Portuguese merchants. Spain imported indigo from Guatemala, whereas others were importing indigo from India. So the indigo, which was very in high demand, was coming majorly from India. So the first revolution, apart from the death penalty and everything, the revolution which it caused was due to the blue color of the denim or the jeans. So denim is also very sturdy cloth, cotton cloth, which has its origin in France, whereas jeans, which is also cotton, but often it is also blended with wool also, had its origin in Italy. So both of them were using, both these cloths were getting used by the working class men, sellers, miners, basically the working class people. So both of them were using the indigo, and the indigo was, maximum of the indigo was coming from India. Of course, the indigo which was produced in Europe also from the woad plant was also getting used. However, the indigo which was produced from the woad plant was not very intense as that which was getting exported from India. So the demand of indigo from India had risen very high. We know Levi Strauss, we know Levi jeans, that's very known to us, very common. So Loeb, who later changed his name to Levi Strauss, he was a German person who went to New York, and they were already, they were into this business of producing jeans and, I mean, denim. They were producing they were cloth merchants who had factories in New York also. And so he and Jacob Davis was a tailor who was working with Levi Strauss. They popularized this riveted blue jeans. So this is very common now. This was not originally there when this denim was being used by these working class men. So why did they do it? In fact, the cloth was very sturdy. It was, after several washings, it didn't get tear off. But the pressure points, like for example, the pockets, the corner of the pockets, those got torn up very easily due to regular use, wear and tear. Those got torn up very, very easily and very fast. So what did these people do? They, used these small copper-based buttons, and at the corners of the pockets, they riveted it. And basically, they use these buttons there so that the corners don't tear off. Once this was done, it became very, very popular. Now everything is there. You have a very sturdy jeans. You have a jeans which is not very, it doesn't tear up very easily, and the color is quite fast compared, and you can use it for so long. And it was used by the working class. So jean or blue denim or jeans, basically that attire, it was a symbol of youth, durability, hard work, because it was used by the working people. It was rebellion. It was a fashion thing. It was in vogue. It was in fashion. So students were using it. Students were wearing it. Women started wearing it. So, and of course, it was also stood for protest. So whenever there was a sort of protest, especially in America, people used to wear jeans. So it is said, so the jeans revolution was caused because partly a majority of it is because of the indigo. Now let us come back to the Indian context. Indigo was grown in India. However, when it was grown in the 16th century to 17th century. I mean, it was in the western parts, Western India, and very few area of your southern India. But basically, it was in the western area, like present-day Gujarat, a few areas of Maharashtra, Madhya Pradesh, and in parts of southern India. However, because of several twists and turns in the history, also, the whole indigo cultivation got shifted into your Eastern India. Eastern India means then Bengal and as well as Bangladesh, major full Bangladesh. So a lot of area in Bengal and Bangladesh, especially in southern Bengal and Bangladesh, indigo was cultivated. The two ways it was cultivated was, one was called as niche, where the these planters were often the landlords, Indian landlords, or the people who were working for the British government. So these planters, they purchased the land from the needy farmers and started the cultivation. So that is one way of the cultivation. And the other way was called as riot. The planters, they give advances to agricultural tenants. The agricultural tenants were farmers, basically the farmers. And certain quantity of indigo will be cultivated on the holdings, and sell the produce to the planters factory. So whatever the farmer had purchased, was allowed to, a certain portion of the land he will be using to cultivate indigo. He may be doing his food crop, but he had to do indigo. Later on, that got mostly converted into mostly 100%. So it was causing a stir. So there were reported gross abuses in the riot system. The needy cultivators, they took loans, and the loans at high interest. Often there was crop failure because of the droughts and the rains, which led to deaths. The food crop was not allowed to grow in seasons. So people were hungry. Whatever land holding I had, a major of it had to be cultivated using indigo. I was not allowed to grow food. I don't have food in my hands, so I'm hungry. My family is hungry. There were rivalry between the Indian landlords and the planters, so often the crops were seized from the farmers. So riots were actually reduced to partial slavery. You work, but no pay will be given to you. So 1859 is what is the major one, but things were slowly it was growing in the background. Along with partial resistance, passive resistance, where people were trying to mitigate the issues through conversation or through meetings, there were also armed revolt by farmers who refused to sow indigo. They attacked the planters and their mercenaries. They burned down the indigo depot. So there was a huge revolution during that time in Bengal, and which led to the formation of the Indigo Commission in 1860. The effect was, it was shifted from Bengal to southern India, to Bihar, north and southern India, where it was not clashing with the food crops. North is basically the staple food item is wheat, so it didn't clash with them. However, it did clash with Bihar and in some parts in southern India. In Bihar, it again led to the uprising in protest of growing indigo for similar reasons which had already happened in Bengal earlier. And by the time Gandhiji had also come back from England, and the first satyagraha was held in Champaran in Bihar, and that is in 1917. So that was the first satyagraha by Gandhiji, because they didn't want to grow indigo. So let us now come to something related to the sources and some chemistry part of it. So natural sources of indigo these are the two major natural sources. One is coming from Indigofera tinctoria, which is called as Neil, and is very often found out all over India, and not only India, in the Indian subcontinent actually. And the other source, which is found in the temperate regions, is Isatis tinctoria, which is called as a woad plant, which we already heard that Europe was producing woad plants. So the tropical areas, you have this Indigofera tinctoria or the Neil, whereas in the temperate areas, you will have this woad plant. So these are the two major species. There are also some minor species which give you some color, but the color intensity for which we obtain from Neil plant is very intense, and is also the amount is also quite high. So how is it extracted from the plant? So historically, these are generally cultivated from April onwards. So you can understand from April onwards means pre-Kharif crop, which is rice, is a major Kharif crop. So pre-Kharif crop is going to be problematic, and they are often cut in July. So ancient times, these plants were squeezed, the plants were beaten, squeezed, mixed in water, kept for many days. They were fermented there, and the insoluble part, which were deposited on the bottom, that was taken out for dyeing. However, modern methods, when I say modern methods, not exactly now, but like during the medieval times also, there was slightly small difference. The leaves were cut, dried, loaded into the concrete vats, which were filled with water, fermented, and the water was allowed to run to very small holes. When the water was allowed to run to the small holes, the indigo which was deposited could not pass through the hole. So those were getting filtered off. So that indigo was taken out and used for further processing. So on my right hand side, I have these pictures which these are photographs taken in Allahabad in around 1877. So you can see it has already shifted now. By 1870, it had already shifted to northern India. So this is in Allahabad, and these are the various stages of indigo plantation and its harvesting. So the first one depicts the reaping, then the cutting of the second one is your cutting of the leaves. The third one is where you put the leaves into the concrete vats and then you press them. Fourth is again you're whipping the leaves. After fermentation, you're whipping the leaves and whatever is there, the pasty mass which has come out of them using your legs. The fifth one is here. These are after that the pasty mass is taken into the factories where they are made into slabs, big slabs. So these big blue slabs, from where then, and the last one is where you cut the slabs into small sizes and take it to the market for selling. Okay, so that was the extraction part. So how is the dyeing happening? Chief component of the indigo dye is indigotin. It's chief component, but however the indigo is a mixture in fact. However, the chief component is indigotin. You have other some other compounds also. During fermentation, one of the chemical which is present in from the leaves and come into the solution, which is also has a sugar moiety. It also has a sugar moiety here. That gets converted into this molecule, which is called as indoxil. So this is indican. The sugar has removed, and this is converted into indoxil. From where it is converted into indigotin. 2 molecules of indoxin, and it gets oxidized, and in fact, it is getting converted to indigotin. So this extract is drained to the next vat and mechanically agitated to produce indigotin. You have to agitate it. That's a way of giving energy to it. And that you're making these indoxyl molecules combine with each other, and there you get the indigotin. The indigotin, after you separate it out, since it's insoluble in water, you separate it out, make it into slabs, and the slabs are sold in the market as cakes. So this is a cake of indigo cake, which is sold in the market. However, you can also get it in the powder form. But how is the dyeing happening? We came to know that indigo is insoluble in water. So how is the dyeing happening? How is it going to dye my clothes if it is insoluble in water? So what happens is that the indigotin, or the slab which is taken, is first converted into a soluble form in water. Using different chemicals, it is converted into a soluble form in water. Indigotin is blue in color. When it is getting solubilized in water because of certain chemical reactions, it becomes greenish yellow in color. So the greenish yellow color has a, this is a form in which you have the greenish yellow in color, which is known as a leuco-indigo. This is soluble in water. You dip the yarn or you dip your fabric there into the solution, keep it for some time, depending on how intense the color you want. it may be how intense. The intensity also depends on the concentration as well as the time you're keeping the cloth there. And then you remove it, you air dry it. So when you're dipping the cloth in this solution having leuco-indigo, the cloth is also not colored. And it's like yellowish white, very light yellowish white. However, when you keep it in drying, it turns blue. It turns blue. So what happens then? There we find that it has again converted into on drying, it gets converted into the indigo tin, which is blue in color. You understanding? So it's such a nice, simple, very, very simple one. You take the slab, you just dip it in water, you somehow you convert it into the soluble form using some chemicals which are readily available to it, and you dip the cloth into it. The cloth is not colored. However, on drying, you find the color has come back. The deep blue color of indigo has already come back. So from all this, we come to, we know, and up till now, we have seen that indigo was in a very huge demand. I mean, people were Europe, America, yeah, wherever it is. It was in huge demand. But the problem was, it is also a hugely cumbersome process. The extraction, harvesting, extraction, and then, the producing the final cake was so laborious method, time consuming method. So people were already started finding alternate routes to prepare indigo. So there were a lot of research going on during that time in different countries. However, the one which we should mention here was by Adolf von Baer. So before I go about what he has done in indigo, just a small, very, very brief biography of Adolf von Baer. He had studied chemistry under Robert Bunsen. So can anyone tell who was this Robert Bunsen? Anything comes to your mind when you hear about this word, Robert Bunsen? The name Robert Bunsen?
We have in chat Bunsen burner.
Great, very nice.
Yes.
Yeah. He was the person who had designed that Bunsen burner. So Adolf von Baer had worked with Robert Bunsen, and then he had also worked with Auguste Kekule. So can anyone tell? How can we relate Kekule to anything in chemistry? Can we relate him to anything in chemistry?
We have, benzene.
Yes, the Kekule gave us the structure of benzene. So we know both of them, right? So Baer had worked with both these people, and for a very long time he had worked with Kekule. Kekule was also along with him for various of his, these different kind of areas in which he had worked. Von Baer, along with his team, of course, was credited with the synthesis of phenolphthalein, fluorescein, barbituric acid. So phenolphthalein was used as a dye, and barbituric acid had medicinal properties. So a lot of research was going on, but he and his team members were credited for preparing it synthetically in the labs. Then, of course, synthesis of indigo, strain theory of triple bonds, and small carbon rings. So Baer had contributed a lot to organic chemistry, and a basic understanding of chemistry also, as well as to the industry, because he had prepared synthetically from his synthesis procedures, which were later modified, was these compounds were synthesized in the industrial scale. So he had done a lot for the industry as well as a lot for the organic chemistry specifically. So what did he do? Baer said in his Nobel lecture, he had told that, I was very fascinated with this color blue. I just wanted to understand what is this color blue. I mean, basically the indigo. He was talking about indigo. So he carried it forward. He first tried to he tried to determine the structure of indigo, whatever the way they had in their means at their disposal. Using those means, he found out the structure of indigo. He first determined the structure by degrading the indigo dye, and found that the main component of the indigo dye was the indole molecule. So here we see the indole molecule. This is my indole molecule. So we say it is a heterocyclic compound. So you have a benzene ring and you have also another 5-membered ring, but with a nitrogen there. So these are called as heterocyclic compounds. So he found that it was an indole molecule. So when he found it out, and after a lot of discussion among his members, they first tried to synthesize indigo from isatin. So this is my isatin molecule. So he synthesized isatin. He synthesized indigo from isatin. Then also he tried it out from cinnamic acid and later on from orthonitropenthaldehyde. All of these gave him not very good results, but what could be done in the laboratory scale. The yields were not very high, the purity was often a problem, but indigo was synthesized in all the 3 methods. But they couldn't be taken to the large scale production. So actually the industrial scale production, because it was very difficult for them to get the starting compounds. The difficulty in obtaining starting compounds, because you also have to depend on the coal tar industry to get certain of the starting materials. So isatin and some of these were obtained from the petroleum industry, the products of the petroleum industry. So getting those was also becoming a problem. Then the synthesis procedure was also quite cumbersome. And often the yields were like 10%, 20%. So those things couldn't be taken into the large scale. So, however, because of so many achievements and because of so many contributions to chemistry, von Baer was awarded the 1905 Nobel Prize in Chemistry for his services in the advancement of chemistry as well as the industry. Then, similar time in Germany also, in Germany only, Carl Humann was also working, trying to find out the methods of preparation of synthesis of indigo. So after a lot of trials in the lab, he found out that this is the main molecule, N-phenylglycine. This is the main molecule which he needs to prepare this indigo. He understood that when he has this molecule, when I have this molecule, the next steps were becoming quite easy for him. So, but for preparing this molecule, he again had to depend on the petroleum industry also, because for that he needed aniline or anthranilic acid to prepare this N-phenylglycine. But he could preserve, but whatever said and done, Carl Humann could prepare from aniline indigo, which was of course low yield, and from anthranilic acid, he got indigo, which was very high yield, but it was very expensive. The whole route was very expensive. However, during that time also, see, up till 1900, both based on von Baer process as well as Carl Humann process, industrial scale of for production of indigo was already on the way. Yield was less, but it had to come into the market because the demand was extremely high. So people were taking it, it was such an expensive thing. So people had already in mind about the profits. So one of the German chemical company, that is BASF, had already brought into the market during 1890s, and they had already brought into the market the slabs of indigo. I mean, the indigo cakes. They had already marketed it from the industrial scale. And that, of course, they were using Carl Humann process. They didn't adopt a Baer process because there were a lot of other trials. So there are a lot of history about it. So I'm not going into history of it. So it was already there. But the yield, since the yield was quite low, people were also looking for alternate methods. So in 1901, John S. Ledger, who was working with Durth and Degussa, which is now Evelyn, he modified the Human's method using sodium amide and had also had it patented. This sodium amide method, using the sodium amide method, was quite efficient. Yield was roughly around 90%. Purity was quite high. The indigo purity was quite high. And also it was much more easier. The temperature had come down roughly to around 200 degrees centigrade, which is like achievable in the industrial scale also. So once this method was developed, it was used by both BASF as well as by Hoist. Both these were German companies and German chemical companies, and they had fully, totally taken the, they had taken it from pleasure and converted into large scale production of indigo. So both this company, BASF was the major one, Quest was also there during that time. So this on the right hand side is the production, indigo production of BASF during the 1890s. You see, this was prior to Johannes Leger's method, which was given to them. So the industrial, we know always, the industrial synthesis had a very devastating effect on the Indian exports, which was bound to happen. By 1930, natural indigo almost entirely was replaced by synthetic indigo, and World War I was also on the way. So there were political repercussions also. So exports had already diminished. Indian exports of natural indigo fell from 187,000 tons in 1895 to 10,000, roughly around 10,000 tons in 1930. So see, within a span of some few years, how much it had decreased. By 1914, BASF was producing around 80% of the world indigo, synthetic indigo. And in 1988, capacity of the synthetic indigo had already reached 14,000 tons per year, out of which 12,000 tons were by these companies only. And few smaller amount was coming from India, China, Mexico, South Korea. So by 2002, the indigo consumption was around 30,000 tons, majorly by the cloth industry, especially by the blue jeans. Plant-derived product makes less than 1% of the total amount of indigo which the textile industry uses. It's just 1% of total amount. Just see how it has decreased. Once when India was exporting it, now India was like, perhaps it has to import something of that sort. However, the synthetic method had its own share of difficulties. There were a lot of hazardous waste products which were produced. So like hydrogen cyanide, formaldehyde, ammonia, amide, sodium iodide, these had to be treated. And when treated, it's not a laboratory scale. These were not getting, synthesized in laboratory scale like 10 ml, or 50 ml. These were getting we are talking in tons. Okay, when I'm talking in tons, you are getting these byproducts, you are getting this, waste products, and you have to treat them. You have to treat them. So the waste products, of course, were treated, but a lot of it was also getting slowly disposed of into the environment. It was polluting the water bodies. Often the industries are near the water bodies. So it was polluting the water bodies. It was polluting the air. It was polluting the land, the soil. So people had already started to use, by the time 2000, people had started to use, find out the synthetic way, but from organic origins. So whether from glucose or using microorganisms, a lot of research has been carried out. It still is getting carried out. But the problem is that when you take it into the large scale handling of bioreactors, there were difficulties in separating indigo from the biomass. Treatment of large volumes of organic matter, these are not very easy. These are very large scales. And when I'm talking about the industry, it's like in tons you're talking about. It's not a small amount like what we do in the lab. So treatment of this waste was also it's also a very, very challenging job. So as of now, whatever information I have with me, we do not have a very biosynthetic method, which is like taken to the industrial scale, but a lot of research is going on. To meet so that at least convert this whole industry into some greener method. Hope so, and I definitely hope so that we should be able to do it in the future, because blue or indigo blue is in huge demand still now. From antiquity, still now it is still in huge demand. So apart from having indigo as a color-giving substance, or it also has shown some potential for applications in medicines, different areas of medicines, which are also in research, under research. People have been trying to use indigo in different ways also. And also it has been used in the areas of organic lasers, transistors. So all these are in the research phases. People are looking into it using indigo and trying to increase its scope. So okay, so yeah, so this is the last slide, and I hope I could take you briefly through a journey about indigo, its historical perspective, the different political pressures it underwent, and also its chemistry and the current scenario of its production and how it changed over so many centuries. So yeah, thank you everyone. So
Thank you, Indrani. So I had
Thank you,
come
ma'am.
across a quote that indigo is a color which has a history as vivid as itself. So indeed, your presentation, your talk takes us through that history, its chemistry, and the developments.
thank
And
you,
I
Vishal.
believe the last at the end that you said that more research is going on in different fields of biomedical and all. So maybe it has a vivid future too.
Yeah.
So with that, I would like our viewers, if they have any question, they can put down in the chat box in the comments. We have one question on YouTube. Is indigo still used for Levi or other blue jeans?
Indigo is used, but it has the indigo which is getting used now is has a synthetic origin. It's not the plant based which is getting used, because plant based to the whole production of indigo, the plant base is roughly 1% of it only. So in Levi jeans is also the indigo which is getting used has synthetic origin. It's an industrial made. But we do have, if not in Levi jeans, but in other dresses, especially in India, we have these, natural indigo made fabrics, which are sold separately. So we have these. We do have that.
Okay. Do we have more questions? Any comments? Thank you.
Okay. Yeah. Okay. Thank you. Thank you all for listening. I hope you have liked the session. Thank you, members
There's
also.
one comment.
Yeah.
So there's no green chemistry route for blue dyes.
Blue dyes as such, I will not be able to say blue dyes, because blue dyes encompass a lot of other dyes also. For indigo, people, that's what I'm trying to say. For indigo, people are trying to find out greener ways of, and of course, when I say greener way also, the hazardous waste products are treated and then disposed of into the environment. That is there, but that's in tons. So sometimes it may happen that some things are not getting properly treated and disposed of. People are looking into it. People are trying to find out different ways, so that this whole thing can be done in much more greener way, with less of the hazardous waste getting produced. There are a lot of research going on.
Okay, so yeah, with that, I would like to thank our viewers for joining us on a Sunday. And you can comment your questions and any comment if you have later. And also you can comment any topic you would like us to talk about in our future Steamboat sessions. So yes, see you all next month on the second Sunday again. Till then, have a nice time. Thank you. Thank you, Indrani.
Yeah, thank you, Vishal. And I would also like to thank the Steamboat members for giving me an opportunity to talk in this session. So thank you everyone for all your support. So I'll stop sharing.
Yes.
So I'm logging out then.
Yeah.
I'll just save the chat. I don't know whether there's any